Electric pole transformers. We see them everywhere, yet often take for granted the big part they play in our everyday lives. Their job is to transform the high voltage from electrical power lines to the lower voltage that is suitable for home use. Transformers lower power line voltage levels to ensure that your appliances don't receive too much electricity. To make a transformer, they start with two materials: paper that's coated with epoxy glue taped to a wooden block, and a 3mm thick aluminium strip, a metal that withstands the heat a high voltage current produces. They secure both materials to the block and rotate it, wrapping the insulating paper and aluminium together. An aluminium bus bar, called the low voltage lead, sends low voltage current out from the transformer. They fold the lead and move the unit to another rotating block for more wrapping. The insulating paper has epoxy glue on both sides. This glue will later melt and bond several components in place. On the next block, a worker tapes on more epoxy paper, then epoxy-coated copper wire. He rolls on a layer of wire covering the paper. Then repeats the same process, forming a second layer of copper wire. Now he solders a high-voltage lead wire to the copper wire, then rolls yet another layer of copper wire. He welds on what's called the lead wire out, the wire that'll protrude from the transformer's cylinder, and vinyl-coated wires that'll connect to different voltages out of the transformer. The component they just built is called the coil. Now using electrical steel, they build the transformer's other main component, called the core. A worker secures the coil and cores tightly together with metal strapping, which will help fix the assembly in the tank, then sends them to an oven, where they'll bake for 8 hours at 135 degrees Celsius. The heat removes any traces of humidity to improve the insulation. The epoxy glue has fused the paper, the aluminium strip, and the copper wires. The assembly fits into a steel tank. They hammer on a rubber gasket around the perimeter and bolt on an earth wire. Then they insert 3 thermoplastic bushings. They connect the low-voltage lead to the thermoplastic bushings, then bolt the bushings to the tank. They adhere an oil-filling guide to the side of the tank, then position an automated filling machine. The machine fills the tank with mineral oil, drawing a vacuum to make sure the oil disperses throughout the coil and cores. The oil is used for its thermal and insulating properties. An internal fault detector will alert maintenance crews if there's a short circuit. A lead wire is run through the thermoplastic bushing and secured in place. Next comes a high-voltage connector. The tank cover is bolted shut. The transformation, so to speak,